So pretty much 1 through 8 are the same exact question. They've just given it to you in different ways. So like 1 and 4 gave you component form. So they gave you your ending resultant of 2 different vectors. 2 and 3 gave you your starting and ending point. So you had to give it in component form. And then 5 through 8 just gave it to you in standard form with the I and the J. But they're basically giving you your X and Y of your component form there. Okay? So for the one where they didn't give it to me, if I want to get my component form, I am going to subtract my starting from my ending. How do I know which is my starting and my ending? Well, I'm going to look at how they wrote it. All right, they wrote it R to S. So that means S is my ending, R is my starting. So if I want the component form here, I am going to say 10 minus -6 and -7 minus 5. And so my component form here will be 16 -12. From that, I can get the magnitude. The magnitude is going to be my distance. I already have my subtraction of my x's and my subtraction of my y's. So to find my magnitude here, I would just say the square root of 16 squared minus -12 squared. And you get 20 there. And then to find my direction, I am going to use my inverse tangent. So I'm going to say the tangent inverse of my 12 over my 16. All right. But then I have to think about what quadrant I'm in here. All right. So when I do that inverse tangent, I actually don't get my final answer. When you do the inverse tangent here, you get 36.9 or 36.86, I guess is what you have, because they did it in 2 decimal. 36.87, right? But look at my resultant vector here. Positive x, negative y. What quadrant am I in?
The fourth.
I'm in the 4th quadrant, and your directions say standard position, meaning like you would do on the unit circle. So I found 36 degrees as my reference angle in the 4th quadrant. I found this right here. That's what I found. But what they're asking for in standard position is from here around. So I have to subtract that amount from 360 in order to get where I actually land in standard position. So when you do that, you get 323.13.
I just got 0.1. Is that okay?
I will tell you how to round it on the quiz. Component form is in the little brackets. Magnitude is the length and direction is the degrees. And so if I want component form, my ending is my B and my starting is my A. So I would say -8 minus a -2 and -5 minus a -9. And so component form here would be -6,4. For magnitude, I'm just going to plug that in. So it's just going to be the square root of -6 squared plus 4 squared. Rounded to 1 decimal place, you get about 7.2. Now here's where it's going to get a little bit tricky. I'm going to do my tangent, my inverse tangent. This is my reference angle. All right. When I do that, I'm going to get 33.7. I think 33.7 is my reference angles. You are always, always, always finding a reference angle. The only time that helps you is if you're in 1st quadrant and you're going from the horizontal standard position. Even if you're in the 1st quadrant and it's a true bearing, you're going to subtract from 90. So you're always finding a reference angle. In this case, I am in the 2nd quadrant, right? -6, +4. I'm right here. So I found this angle. That's what I just found. I need this one. So I need to subtract that from 180. 180 minus 33.7. And that's where I'm going to get the 146.3 degrees. And those 2 answers would be my final there.
So how do you know which angle you need?
So if I were to slide this up here, if I were to take, let me grab them real quick. If I were to take this and slide them up here, it's the same thing.
It's the exact same thing.
It's the exact same thing. And so I am looking at direction strictly. So my direction here is from A to B. when I find component form, this -6,4 can go anywhere on the axis, but I know that I'm going left 6 and up 4, which means I know for a fact that my vector is going to be right here. Now, it could be anywhere on the coordinate plane, but that vector represents my vector. And so I know I have found, when I did that with SOHCAHTOA, I know I found this angle because I could put the y over the x. So I know I found that internal angle. But if they want it from in standard position, which is what your directions say, that's like unit circle. Unit circle. So that means you start at the x and go counterclockwise.
Okay.
Now, if it said true bearing, that's when you start at north and go clockwise. So some of your word problems say true bearing, and that's north and clockwise. And clockwise. So this says an Antarctic expedition drives their snowmobiles 185 miles south from their camp. They then turn and drive 70 miles west. Now it is time to return to the camp. In what direction must they drive, and will they make it on 190 miles worth of gas? So I'm going to draw a coordinate plane here. So I'm going to draw this just to give myself a visual of what they're doing. All right. And our infamous north, south, east, and west. All right. So they drove 185 miles south. That means they went this direction. And the length there is 185. Then they turned and drove west, which means they went this direction for 70 miles. Now, what's nice about this word problem is I know that if I go south to west, I created a right angle. Okay, so those are easy kind of in that particular thing. Now, the question is, how must they travel back? Now, they are asking for a true bearing here. Okay, now the closest distance between 2 points is a line, right? And so I'm not going to go on this curvature path, and I'm definitely not going to go the way that I came. I'm going to travel on the hypotenuse here, okay? And so I want to go straight from here back to their camp right there. So this guy is easy to find, right? How do I find that one? That's my magnitude. It's the magnitude formula. It's the square root of my 185 squared plus my 70 squared. What do you get when you get that? 197.8. So it's easy to answer the question, will they make it back? No, I mean, not in their vehicles, on foot maybe, but they will still be 7.8 miles from camp when they run out of gas. So sorry for them, but no, they will not make it back on the gas. All right, the other question is, what direction must they travel? So we're talking about true bearing, right? We know they have to travel northeast, okay? That's common sense. But I need to give them, like, we're in the middle of the Antarctica. So if I say northeast, that is a whole quadrant, right? From north to east is a whole 90 degrees. And so it's important that they go 197.8 miles in a specific direction. And so I can solve for this angle here. That's perfect. But I will need to do something else to actually give them their bearing, their true bearing. I'll need to subtract from what? 90. From 90. Because I actually want to give them this angle. And so you're going to use your tangent there, inverse tangent here. But we are going to have to subtract that from 90. And that will give us the 20.7 degrees. And they are going northeast. Or you could say, you know, if you want to do with decimals, you want to say northeast.
And you went ahead and subtracted by?
So if you wanted to, you could have said the initial travel was 0, negative 185, right? And the secondary travel was negative 70, 0. And then you could add those together and get your vector. You would have done the same magnitude. You would have done the same tangent. You would have known you were in the fourth quadrant. And so you would have known how to tell them to travel. So you can always set it up as really two vectors there if you want to.
So basically you can